By expressing 1 in polar form and using Dunois's theorem, find the solutions to z cubed equals 1 in polar form. When you're working in real numbers, you know the only solution is 1. However, we can say here that z cubed is equal to cis 2n pi, because every time we get to 1, no matter how many times we go around the graph. That means that z is equal to cis 2n pi divided by 3. Now, I can use n is equal to -1, 0 and 1 here, and that will give me that z is equal to cis -2 pi by 3, cis 0, and cis 2 pi by 3. Convert the roots into exact Cartesian form. So, for the first one, we're going to get cos -2 pi by 3 plus I sine -2 pi by 3. So that is going to give me -1/2 take away I root 3 on 2. And that's just knowing the values of the cosine and the sine. These are standard angles, so between that and the cast diagram you should be able to work those out. Then we have z is equal to 1, that's cis 0, and then for this one is cos 2 pi by 3 plus I sine 2 pi by 3, which is that z is equal to -1/2 plus I root 3 on 2. What is the sum of the three roots? So we've got -1/2 plus I root 3 on 2 plus 1. Take away 1/2 plus the first one was take away I root 3 on 2. This one is plus I root 3 on 2. So if we look at the real parts, -1/2, 1, -1/2, that's 0, and those two will cancel out as well. So the sum is 0, same as it was in the previous example. Display the roots on the grid below. So one of them was 1. Then we had cis 2 pi by 3, and I think I've got that one in the wrong place. I think it is there. And so there's this nice symmetry about this, and it's always going to be the case. It's really nice. We can see there's 120 degrees between these roots. You can also see, thinking of them as vectors, why they sum to 0.